And the other oxygen, an idea for another symbol I could use rather than a dot or an X? An O? Okay, that's what I was considering that. I'll go with little O's. This way we can keep the electrons that came from which atom straight. So we've got dots, little circles, and X's. Let me make sure I get this right. Over here, the sulfur could bond here and bond there. Now, everybody's got an octet, actually. The sulfur has 8 electrons to his name. The oxygen has 8 electrons to his name. The issue is, this oxygen only has 6 electrons to his name. And I told you that the molecule is SO2. In order to make this happen, here's what will happen. The electron from over here will move over there, and 2 electrons from the sulfur will make, 2 electrons from the sulfur will make a single bond with the oxygen. Let me be clear, because a shared pair of electrons is only a single bond. None of the electrons in this bond come from the oxygen, both of them come from the sulfur. Why does it do this? I don't know exactly, but it does. Now, that it does, look at this molecule for a second. Notice the one side of the molecule had 2 conventionally formed covalent bonds. The other side had 1 unconventionally formed covalent bond. Now, who's to say which bonds happen on which side of the molecule? I don't know. I mean, I could have just as easily done this. Here's my sulfur. Here's my 1 oxygen. Here's my other oxygen. Just as easily, I could have taken the 2 lone bonding sites from the sulfur and bonded them to the 2 lone bonding sites on the oxygen with circles for its electrons. I could have just as easily reconfigured the electrons from the oxygen and taken a pair of the sulfurs to form a single bond here. Who's to say which way I would draw it? This is an example of resonance. A molecule that can exist in multiple configurations. Now, because you could double bond to the left molecule, the left oxygen, or double bond to the right oxygen, and it really doesn't matter, you could have this molecule exist in multiple configurations. The standard way to write this molecule, when you write it out in a picture, the standard way to draw it, I should say, the standard way to draw the molecule, is rather than having a sulfur with a single lone pair and 2 bonds to this oxygen and 1 bond to that oxygen, or a sulfur like this let me make sure I get this right here. A standard way that you may see this drawn, and I guess it's not the only way that you may see this drawn, but this is a way, is to draw little dashes there, rather than, like, and the dashes are just saying, this bond could be on the one side, this bond could be on the other. Which side that bond is on is anybody's guess. That would be a way to draw that. A way to draw that. The dashed lines are saying it could be a bond there, it also could be a bond on the other side. This would show the resonance, saying you could have it on one side, you could have it on the other, and it really doesn't matter which side it's on. Because it would be silly to make a choice. When who's to say which oxygen was the one that bonded double, and which oxygen was the one that bonded single? Resonance. Nothing too fancy, but just something to be aware of, I suppose. Don't forget next Thursday, we'll have a test on bonding.